All right, here we go. We are going to get into our next section here. We're going to talk about verifying the link state database in this case. This is an interesting section here because what we're going to be talking about is all of the different LSA types that exist in OSPF. This is going to be our topology, kind of the basic topology that we've been using throughout the course. But the interesting thing about this is we're going to be able to go through and kind of discover really how OSPF exchanges all of the information that it learns with all the other nodes in the topology. And that's really the goal here, is to be able to understand what is an LSA type 1, what is an LSA type 2, LSA type 3, and so on. And so that's what we're going to be taking a look at. So let's get into a little bit of our discussion first, and then we'll get into the actual exercise as part of the process. All right? So when it comes to exchanging link information with other routers in our topology, we typically do this with link state advertisements, right? Each type of link state advertisement has a particular purpose, has a particular meaning within the OSPF topology. You can see from the table here that we have type 1 LSAs, we have type 2 LSAs, type 3 LSAs, type 4, type 5, type 6 through 11. All right. So I want to kind of go through each one of these with you so that you can understand really what the meaning is of each of these different types of LSAs. The ultimate goal, of course, is to advertise reachability information, or what we call network layer reachability information, to all of the routers in our topology. And typically with other routing protocols like EIGRP or RIP, we're basically advertising prefixes and next hop addresses and exit interfaces. But these different LSA types in OSPF have different kinds of meanings. All right. So for example, a router LSA is generated by specific types of routers in our network topology. A network LSA is generated by specific types of routers in our topology, and so on. So the entire purpose of this discussion, and then ultimately the lab that we're going to be doing as part of this discussion, is to identify who generates the different types of LSAs, what the purpose of those LSAs are. We'll take a look at them in Wireshark. We'll take a look at them in our database and really try to get a strong understanding of who generates different types of LSAs in the topology. You can see from the diagram here that there are some basic concepts with how LSAs are processed, right? You can see some of those LSAs are what we call intra-area LSAs. An intra-area LSA is an LSA that has a scope within the area. An inter-LSA are LSA types that move from one area to another. So for example, a type 3 LSA is an inter-area LSA. A type 1 LSA or a type 2 LSA is an intra-area LSA, meaning that it only stays within the area. Type 5 LSAs are inter-area LSAs. Type 4 LSAs are inter-area LSAs, and so on. So the important concept here is there's basically three things that you want to learn when you're talking about different LSA types. Number one, who generates that LSA? Who is responsible for generating that LSA? Number two, what is the scope of that LSA? Where does that LSA propagate to? And number three, what is the purpose of the LSA? What is its use? What does it describe in the topology from a link state perspective? And that's really what we are trying to determine in this particular case. All right? So each time I talk about a different LSA type as part of this process, I'm going to talk about who generates the LSA, what is the scope of the LSA, where does it propagate, and what is the purpose? What information is contained within that advertisement that allows the routers to share and collect information. So that's ultimately what we're talking about here. All right, so we'll start by kind of going through the details here, and then we'll take a look at this as part of our discussion in our lab exercise. So let's start with a type 1 LSA. A type 1 LSA is an LSA that's generated by every single router in OSPF. It's really kind of the most fundamental LSA that you can have in an OSPF network. The type 1 LSA describes the links that are local to that particular router. So these are really literally the link state LSAs that allow me to identify what types of networks are attached to my particular router. All right, now it says here every router generates these type 1 LSAs. These type 1 LSAs are flooded within the area. So that means that they are intra-area LSAs, not inter-area LSAs. They do not leave the area. All right, now it also talks about here for these different types of LSAs, there is a 20-byte LSA header. I will show you guys that in the Wireshark, what that looks like in Wireshark. And then one of the fields in that header is something called the link state ID. This is something that shows up in the OSPF database when we look at the OSPF database, and it verifies the basically the originator of the link state advertisement. All right, meaning that it identifies either the network that's being advertised or it identifies the originator of the LSA itself. In the case of a type 1 LSA, the link state ID is the router ID of the individual that's actually generating the LSA. Okay, so and we'll see this. I'm going to show you guys this in the lab exercise. We'll kind of do a deep dive and we'll take a look at this in the lab exercise. These are called router LSAs. You'll see that in the database listed as a router LSA. And again, the who generates them? Everybody. Number 2, what is the scope? The scope is inter-area, so within the area. And then finally, what does it describe? It describes the links that are attached to that particular router. The second type of LSA is what we call a type 2 LSA. A type 2 LSA is generated by DRs, designated routers. We talked about the DR concept previously in our previous discussion, right? A designated router is the chief or the master of the broadcast domain. It's the one router that forms a full adjacency with all the other routers within that multi-access segment, and the responsibility of the DR is to disseminate routing changes or topology change information within that particular multi-access segment. So these are called network LSAs. Type 2 LSAs are called network LSAs. They are generated by DRs. The scope of a type 2 LSA is within the area, intra-area LSA, and the purpose of a type 2 LSA is to describe the network that the DR is managing, okay? So it doesn't specifically describe prefix information. It doesn't describe an actual network address and prefix. It's there to describe the segment or the network that the DR is managing. Not only does it describe that segment, it describes whoever is attached to that segment. Remember when I told you guys in the beginning of this class, I said OSPF is more about routing to nodes than routing to networks. The DR is responsible for all of the nodes on a multi-access network. So that means that the other routers in the topology need to know, hey, if I need to speak to those devices, if I need to speak to those devices on that multi-access network, I really need to send my information to the DR, because the DR is the one that's going to be responsible for propagating that information to the rest of the nodes on that multi-access segment. Does that make sense? So that's what we're talking about in this particular case. So the DR generates these network LSAs. The network LSA describes the routers that are attached to that particular multi-access network. And again, when we get into our lab exercise, we're going to take a look at all of this information as part of the lab exercise. Network link advertisements are flooded in the area, and the link state ID is the ID of the IP address of the DR. So not the router ID of the DR, but the actual physical IP address of the interface that's participating in that multi-access segment, okay? So we talked about router LSA, we talked about network LSA. The next is a type 3 LSA, which is a summary LSA. And the type 3 LSAs are inter-area LSAs, meaning they move from one area to the other. There is an exception to that rule. A type 3 LSA will not go into a stubby area or a totally stubby area or a totally not so stubby area. Type 3 LSAs will not go into those area types. They will go into a stub or a not so stubby area. We'll talk about that in another discussion, right? Who generates these LSAs? These are generated by ABRs, area border routers. So if we look at our topology here, router 1 is going to be generating these type 3 LSAs, okay? Router 4 might be generating type 1s, maybe possibly type 2s. This is a multi-access segment, so it is possible that router 4 might generate type 2s if it is a DR, but those type 1s and type 2s stay within area 0. Router 1 generates the type 3s, okay? Router 1 generates the type 3s. Now, what is the purpose of a type 3 LSA? The purpose of a type 3 LSA, it's called a summary LSA because it's supposed to represent a summary of all of my type 1 LSAs. So let's say in area 0, I have 1,000 type 1 LSAs. These are LSAs that represent all the different links in area 0. It doesn't happen automatically, but it is possible that you would take those 1,000 LSAs and summarize them as one type 3 into the other areas. We haven't done summarization yet. We will be talking about summarization, but summarization is a way for us to take a bunch of networks and advertise them as a single congruent large subnet, if you will, or supernet, to reduce the size of routing tables. We talked about that in one of our previous discussions, right? So who generates type 3 LSAs? An ABR. What is the scope? It's inter-area. And what is the purpose of a type 3 LSA? It describes or it represents a summary of type 1 LSAs. All right? So the ABR takes information that it learns from one area, say area 0, and it describes that information as a summary into other areas. The summarization is not done by default, unlike say RIP or EIGRP, where summarization can happen by default. It doesn't necessarily have to happen by default, but it can. We don't do that by default in OSPF. Summarization only occurs if you decide to configure summarization on an ABR. And one of our next lessons here, we're going to be talking about how to create summaries on an ABR and how to create summaries on an ASBR a little bit later on. Okay? The link state ID for a type 3 LSA is the destination network. In this case, that means the summary. And again, we will see all of this when we actually get into our lab exercise and we start kind of seeing this in practical case. That's the best way to really learn these LSAs, is to look at it in a practical scenario. That's really the best option for us, is to look at it in a practical scenario. Type 4 LSAs are kind of interesting. These are ASB summary LSAs, Autonomous System Boundary Router summary LSAs. They call them ASBR Summary Link State Advertisements. The purpose of a Type 4 LSA is to describe to the rest of the OSPF domain the existence of an ASBR. This gets a little confusing because, again, unless you see this visually, which we will, it really is difficult to understand. Type 4 LSAs only exist if you have an ASBR. An ASBR is an external router that redistributes routing information from another routing process into OSPF. That ASBR can be attached anywhere. But let me kind of draw a diagram here, because I think it would be easier kind of generally to understand what we're talking about in this particular case. Type 4 LSA can be a little bit confusing. So let's say, for example, I've got a router here, maybe. It's thinking. Let's change my pen size here. Oh, it's not letting me do that. I'll tell you what, I will, I don't know why my touch screen's not working, but let me, yeah, it's not working for some reason. Okay. Let me just do it this way then. So let's say I have, I've got an area here. This is, say, area 0, and I've got another area here, and this is area 1. Just forget that those are little clouds, and my touch screen is not working for some reason, but that's area 0 and that's area 1, and I've got an ABR here. All right, so this is an ABR, and this ABR is here to describe, or to pass traffic from one area to the other, like we would typically see. And then in this area here, I have an ASBR, an autonomous system boundary router, that is taking traffic from a non-OSPF area and sending it into OSPF. Now those are going to come in as type 5s in a normal area. We haven't talked about the type 5s yet, type 5, or possibly a type 7 if it's a not so stubby or totally not so stubby area. Those represent my external networks. We'll talk about that in a little bit. The type 5s will propagate through as type 5s. So they stay type 5s, even though they might leave the area. Type 5 LSAs or LSAs that propagate through throughout the entire topology, if you will. All right, we'll talk more about a type 5 LSA. We haven't quite got there yet. Type 7s will get converted to type 5s once they pass the ABR. But remember, we're talking about those type 4s. The type 4s are going to be generated by the ABR that is attached to the area that has the ASBR in it. Those type 4 LSAs are propagated to the rest of the network. All right, so the purpose of a type 4 LSA, and again, this is something that we kind of have to see in action, but the purpose of a type 4 LSA is to describe reachability to an ASBR. It's to describe reachability to an ASBR. And we can see what the description that they provide here is. A type 4 LSA. It's a summary link state advertisement that informs the rest of the OSPF domain on how to get to the ASBR. So it provides reachability information to the ASBR. Again, it is all about routing to nodes. It's all about routing to nodes, not routing to networks. And also, it's really important, I can't stress this enough, it's really important to see this kind of stuff in real time, looking at the lab. So I'm going to show you guys this here in a little bit. All right, so the link state ID includes the router ID of the ASBR. Remember, the ABR is the one that's generating this type 4 LSA, but it's describing reachability to the ASBR. And for that purpose, it has the ASBR's information. All right, type 5 LSA, another very common type of LSA. A type 5 LSA describes external networks. Type 5 LSA is what we call an external LSA, and it describes networks that are being redistributed into OSPF. There's only one type of router that generates type 5s. That's an ASBR. Okay? Remember the three things I said. Who generates the LSA? What is the purpose of the LSA? And what is the scope of the LSA? And I'll go back and kind of review these again as we go through the process here. All right? Well, so a type 5 LSA describes the external networks. So those are the redistributed networks from an external routing domain. The type 4 LSA describes the ASBR. So the type 4, you would never have type 4s without type 5s. You would always have type 5s would always result in the generation of type 4s. But they describe completely different things. A type 4 doesn't exist in the area that the ASBR is attached to, unless they're type 4s from another area. But the type 4 tells everybody else in OSPF, how do I get to the ASBR? Type 5s describe the actual redistributed networks. And I'll demonstrate this as well, all right? Now, type 5s will go everywhere except for special area types. Type 5s do not propagate into any OSPF special area. That would be stubby, totally stubby, not so stubby, or totally not so stubby. You would not see type 5 LSAs in any of those special areas. All right? Now, there are some other LSAs. Type 6 we don't see too often. These are very specialized LSAs that are used to describe multicast networks. Type 7s you would see. A type 7 is basically a type 5. It just happens to be an ASBR that is in a special area type. So type 7 LSAs are LSAs that are generated by an ASBR that is in a not so stubby area or a totally not so stubby area. And again, I will demonstrate these concepts because it's really confusing. There's a lot of information here. It really is important that you see it in action, right? You see it in the databases based on the topology that we have configured. Type 8s and 9s, these are for OSPF v3, specifically OSPF for IPv6. Type 8 will describe link local information, those link local addresses that we have in IPv6. And type 9 will describe intra-area prefix LSAs, are standard router LSAs, but we use a different type of LSA to describe those intra-area prefixes. Remember, intra-area means stuff within the area, okay? And then type 10 and 11, we don't really see too much either. These are what we call opaque LSAs, and they're primarily designed for future use or future extensions of OSPF to carry information that might be deemed necessary later on, okay? So in our topology, again, if we look at our topology here, R1 is acting as an ABR in this topology. R4 is acting as a backbone router in the topology. R2 is an internal router. And then R3 is acting as an ASBR because we're taking these external networks that exist in this green circle and we're redistributing them into OSPF. So in area 0, I'm going to see type 3s. Well, I'll see type 1s and 2s for sure because I have a multi-access segment here. So I'm going to see type 1s and 2s in this area. I also am going to see type 3s. I will see type 5s because the 5s will be these external networks. And I'll see a type 4, which is going to be generated by R1 to describe reachability to R3. In area 1, I will definitely see type 1s. I may not actually see type 2s. On a point-to-point serial link, we don't do a DR-BDR election, so it's possible that we would not have type 2s. It depends on how this network is defined, if it's point-to-multipoint or if it's described as a frame relay link, not HDLC or PPP, then frame relay would have a DR, potentially a DR-BDR election. It is a non-broadcast multi-access network, so you could have a DR-BDR election there. So I could see type 2s there, but I would definitely see type 3s, and I would definitely see type 4s and type 5s. Again, the type 3s would be all the other prefixes that are type 1s being advertised into area 1 as a type 3. The type 5 LSAs would be coming from router 3, and the type 4 LSA would be originated by R1 to describe reachability to R3. All right? So you can see where it can be a little bit confusing. We've got a lot of things happening with these routers here. Lots of different LSA types, lots of different purposes for these LSAs. So that's a really, kind of a really important concept to understand. All right? And we're going to get into this topology and take a look at that as part of our discussion here. All right? Now, this table basically describes, essentially, if we go from OSPF v2, which is classic OSPF, if you will, to OSPF v3, which is the address family mode configuration that we've been working with over the past day and a half. Type 1 LSAs, called router LSAs. They're also called router LSAs in OSPF v3, generated by everybody. Intra area scope, meaning within the area, and they describe the links that are attached to the router. Network LSAs are called network LSAs in OSPF v3. These are my type 2 LSAs. They are generated by DRs, designated routers, and those describe the multi-access network that the router is attached to. And again, I'll demonstrate this as part of the process. Now notice here we did rename the network summary LSAs, these are my type 3 LSAs, to inter-area prefix LSAs. They have the same meaning, they have the same format, but the purpose of an inter-area prefix LSA or a network LSA, summary LSA, is to describe summaries of those type 1s that come from other areas. ASBR summary LSA, type 4, again to describe reachability to the ASBR, was renamed to inter-area router LSA with OSPF v3. AS external LSAs, called AS external. AS, of course, stands for autonomous system. So an AS external LSA is an LSA representing a network that was redistributed into OSPF. Multicast, we don't really talk about. NSSA external, not so stubby area, is a type 7, which is basically an external LSA coming from a ASBR that's attached to a special area type. And then a multicast LSA, a type 7 LSA is what they renamed it to in OSPF v3. All right. In OSPF v2, we don't have 8s or 9s because in OSPF v2, that's IPv4. 8s and 9s are used to describe IPv6 concepts and IPv6 LSA types. All right. In fact, we kind of see that right here. This is just the renamed LSA, the inter-area prefix LSA, known as a type 3. We know what the purpose is of an inter-area prefix LSA. It's used to represent a summary network of all those type 1 LSAs from other areas. All right. But we do have the inter-area router LSA as well. That's type 4. So those are the renamed ones. I talked about those just a minute ago. Some new LSA types. In IPv6, we use link local addressing a lot, right? Link local addressing, the FE80 /10 addresses are used in IPv6. So these link LSAs allow us to describe that link local information. Notice that these link LSAs have a local link flooding scope, which means they're not even passed throughout the area. They're only passed to somebody in a common subnet, which is kind of important. All right, this is the only LSA type that doesn't even have a full inter-area scope. It's only passed to the next router on the segment, on a common segment, and these provide the link local addressing information. It kind of makes sense these would have a link local scope because link local addresses in IPv6 have a link local scope. You understand what I mean by link local scope, meaning it doesn't go beyond the broadcast domain. All right? And these inter-area prefix LSAs, which are type 9s, and these basically represent, and I'll demonstrate these, I'll show you these in our lab, but these represent basically the prefixes that exist because IPv6 has the capability of supporting multiple addresses on a particular link, we use these LSAs to describe those networks on that link. So it's very much almost like a type 1, but because of its scope and the purpose, but it is slightly different. We'll take a look at that in the lab as well. All right, so this diagram kind of gives you a representation of who generates the types of LSAs, what the scope of those LSAs are. Network and router LSAs, type 2 and type 1 respectively, are intra-area LSAs. Type 3s are inter-area. Type 4s are inter-area, meaning they will propagate beyond the next area, but they're generated by an ABR. And then the AS external LSAs are generated by an ASBR, and those are also inter-area LSAs. All right? So that being said, let's go ahead and get into our discovery, where we're actually going to take a look at this in actual command line. And I'll play around with it and kind of change the configurations up a little bit, give you an idea of what this looks like as we kind of play around. And I'll do a Wireshark captures and debugs and whatnot, so you can see how these LSAs are treated. So in this discovery, we're going to analyze our OSPF v3 link state database. Remember, we're running address family mode OSPF in this particular case. All the routers have already been configured with OSPF v3 for IPv6 and IPv4 using address families. So we're going to have access to all of the routers, including the external router. Router 1 through 4 are already configured with OSPF v3, and the external router, being that it's not part of the OSPF domain, is only going to be running static routing or static routing or connected routes and so on. All right, we're going to focus our attention on IPv4 in this particular case, but the reality is I'll take a look at some of the IPv6 concepts because that's important to see. But the reality is that the database doesn't really change if you're doing v4 or v6. Yes, granted, there are some new LSA types, type 8 and type 9 in IPv6, but with regard to all the other LSA types, they're the same in v4 and v6. A summary LSA in v4 is the same thing as the summary LSA in v6, okay? So we're going to investigate the router LSAs. Those are my type 1s. We're also going to take a look at the intra-area prefix LSAs. Those will be the ones that in IPv6 or OSPF v3 that stay within the area. We're going to take a look at the network LSAs, which are my type 2s, which are generated by my DRs. We're going to take a look at the inter-area prefix LSAs, which are basically my type 3s. We're also going to take a look at the inter-area router LSAs. Those would be my basically my type 4s, right? ASB summary LSAs. Again, remember, we're talking about, in this case, these the OSPF v3. Some of you are probably familiar with the OSPF v2 concepts. So the terminology might look a little bit differently here because we're using OSPF v3 in this particular exercise. But in this particular case, we are talking about the type 4 LSAs, then the type 5s, and then finally the type 8s. All right? That's going to be kind of our progression here. So we're going to take a look at the database on R4, we're going to take a look at the database on R1, and I will actually kind of be going back and forth between the topology and the command line to make sure that we can kind of correlate what we're seeing in the command line versus what we're seeing in the topology. I think that's a really important concept as well. All right? So this is all the device information. We don't really need to take a look at that right now. Let's start by going into the into router 4, and let's take a look at the routing table on router 4. Let me just change this real quick. The wrap is not good there. There we go, that looks better. So we're going to take a look at the routing table in router 4 just to make sure that we have all of the routes that we would expect to see. So let me go into, I think I already have all the command line stuff open. I just have to pull it up here. So let's go into router 4, and we're just going to do a show IP route. And we should see different types of routes here. Now, this is another important concept. the code that represents the route actually has a direct correlation to what type of LSA was used to disseminate that information, right? An O route, for example, is a type 1 route. That is a route that was learned inside of my area. So this route was learned through the use of a type 1 LSA. An OIA route was learned from another area. IA stands for inter-area. So this would correlate to a summary LSA, a type 3 LSA. All right? E2 as well as E1. E1 and E2 are basically the same. The only difference between E2 and E1 is how the metric is calculated. E2 doesn't increment the metric, whereas E1 does increment the metric based on whatever the seed metric is when you do the redistribution. But an E2 route is an external route, which basically represents a type 5 LSA. All right? An N route, we don't see those here. I might change the configuration so we can generate some, but these are type 7 LSAs. N stands for not so stubby. So these would be external routes in the area, the special area that the ASBR is attached to, which would be where the type 7s exist. Those type 7s would then become type 5s as you leave the area. Okay? So again, it's a lot of information. It can be very, very confusing, but we will kind of break this down. So let's see what we've got here. We've got where this is on router 4. So looking from router 4's perspective, I should see type 3s for network 12, network 2, network 13. I should see type 3s for those, which would be OIA routes. So let's see if that's what we actually see here. There's 12, there's 13, there's 2, and it looks like there's a bunch of other loopbacks as well, all coming from the ABR. So it looks like there's actually a bunch of loopbacks. I'm guessing that's going to be on router 2. Let me see real quick. No, it's not on router 2. Must be on router 3. Nope. So where are those loopbacks coming from? Let me go back to router 4. We've got 18, 19, 20, 21, 22, and 23. They have a cost of 75, which indicates that that's a serial link. They are coming from router 2. They don't show up as a primary address, but if I do a show run interface loopback 0, we have a bunch of these secondary addresses configured on the interface. So it's just to generate additional networks in the topology. So they don't show up in the show IP interface brief output because only the primary address shows up in the show IP interface brief output. But these are just additional networks that we're injecting into OSPF just for the purposes of having more information in our database. So we see what we would expect to see there. The external network is the 10 network. And again, that's kind of what we expect here. There's the 10/16 subnet. So that's being redistributed into OSPF. So from a routing table perspective, we are definitely seeing the routes that we would expect to see. Okay? It looks like in the case of the lab here, those secondary addresses should not be injected, but that's okay. It doesn't matter that they are. They're probably going to be used. I think I added those at one point to do summarization, to be able to summarize and show you what summaries look like, but which I will do, by the way, as part of our exercise here. So show IPv6 route, let's go ahead and do that on router 4. And again, really we should just see what we expect to see. Very similar to V4. There's the OIA, there's the OIA, there's the OIA. We don't have any of those secondary addresses. There is the external route that's coming from the ASBR in area 2. And then there's the 11 network that's coming from this loopback right here in router 1, right? So that's exactly what we would expect to see. All right, So our routing table looks like it's fully converged. We have those, like I said, the O routes, which are our intra-area routes. We have the OIA routes, which are our inter-area routes here and here. And then we also have that external route that's not listed here. And the same thing on in our V6 environment. The 12 and the 13 are the point-to-point links between the non-backbone routers and the ABR, and so on. So far, so good? So we're seeing everything that we expect to see here. Now, let's take a look at the database. Now, in the case of OSPF v3, if you recall, we only really have one database. We can drill down to the v4 version of that database. We can drill down to the v6 version of that database. But OSPF v3 kind of combines those databases together. And let's take a look at what we see here. Now, when you do the command show IP OSPF database, or you run the command show OSPF v3 database, you are looking at a summary of the database itself. When we did EIGRP, we took a look at the topology table in EIGRP, and the topology table was really kind of representative of the overall topology of the network, right? We saw prefixes, we saw prefix links, we saw next hops, we saw feasible distances, we saw reported distances, and so on. When you look at an OSPF database, it doesn't look like any kind of routing information. I mean, you look at this and you say, well, okay, there's some prefixes listed here, but there's no prefixes listed here. There's no prefixes listed here. So what am I actually looking at, right? Well, you're looking at a summary of the database. And you can drill down into the database by referencing specifically router link states or Netlink states, which we're going to do. But for now, let's just go ahead and kind of take a look at this summary first. Remember, this is on router 4. And you always want to kind of reference the diagram so you can get a good understanding of how the database represents what's actually happening in the topology. Router link states, from router 4's perspective, I should see two links from router 1, the link that router 1 is attached to, the common subnet that it's attached to, as well as the loopback interface, and I should see one link for router 4. And we kind of see that here, right? Router 1 is advertising one link. Router 4 is advertising one link. And then, well, we can actually kind of break this down and go into this and take a look at it. Now, one of the things that I want to mention, I'll talk about the link state age a little bit later on. Now, we talked a little bit about in our introductory section the concept of a paranoid update in OSPF. The link state advertisements have a max age of about 30 minutes. And that's what this age kind of represents before we do our flooding. The sequence number represents the number of times that the link state advertisement has been updated. Remember, that starts at 001, right? I didn't read the whole number, but it starts at 001. So each time there's an update to a particular advertisement, every time there's an update to an advertisement, that number is going to increment by 1. So that means that in this particular topology, I have received 2 updates for that particular link state advertisement from router 1, also router 4, and that has to do with just turning on the routers and whatnot. Now, you look at this. I'm going to break down the rest of the LSA types here, but let's go step by step here. A router LSA, if you recall, is a type 1 LSA. It is generated by everybody in the topology, everybody within the area. And router 4 is in area 0. So these are the LSAs that I'm learning from area 0. Now, if I want to see what the contents of those specific LSAs are, then I type show IP OSPF database router or show OSPF v3 IPv4 database router. And this is where we can actually see the details of this particular link state advertisement. Routing bit means that this particular network prefix is reachable. It is possible that you can learn about prefixes and destinations that are unreachable because the particular node is not reachable. Even though we might be learning the routing information, The node might not be reachable. These are the options that describe what the router's capable of. We talked about this a little bit earlier. External bit means it's capable of injecting external routes. The R bit has to do with the DBD synchronization. The AF bit is the address family bit, and so on. These are type 1 LSAs. The advertising router, this is the router ID of who's generating this LSA type. In this case, that happens to be our ABR, our router 1, which is our ABR. This is how many times the link state advertisement has been updated. The checksum. This router happens to be an area border router. All right. This LSA doesn't describe, type 3 LSAs, but this router happens to be an area border router. And then you get to see the actual information about the link. This is the router ID, and so on. So this is a little bit different than what you would expect to see for a router LSA in OSPF v2. A router LSA in OSPF v2 will actually give you the prefix information. It will give you the metric and so on. But remember, we're running OSPF v3. So if I do a show IP OSPF database, there is another set of LSAs that we have to look at right here. My intra-area prefix LSAs. This is going to describe the actual prefix information. So that's what I was telling you earlier. The type 9 LSAs are kind of paired with or similar to the type 1 LSAs. All right? So let's take a look at those type 9s real quick, since they are related to our type 1s. Now, these are all of the different LSA types that we have. All right? This particular intra-area prefix link states, which one of these do you think I'm going to use to look at those link states? Now, link right here, that might be it, right? Because we're talking about intra-area prefix link states. But let's take a look at what the links represent. And sure enough, it represents exactly what we would expect it to represent. So these are my type 9s. Well, actually, these are my type 8s, excuse me, which represent my link local information. And let me see. It's not showing me what I expect to see. Let me see which ones do I want to look at? Actually, that is true. Let me look at the V6. If I look at the V6 database, we're going to have some different options because we have link, but there was one other one that I was looking for, which happened to be the link local ones. And I believe it would be internal, if I'm not mistaken. Let me go back to that because I don't want to kind of get away from what I was talking about previously. Let me cover this first, these type 8 LSAs. And if we go back to our book here, we can see what those type LSAs represented, right? And this is kind of interesting because not what I expected to see, actually, because the type 8 LSAs are supposed to represent, these are my link LSAs, not my intra-area prefix LSAs. So the type 8 LSAs should represent the link local information. And that's interesting here because I'm not seeing link local information in this output. So I must be, let me do one more thing here real quick. Let's do a self-originate, and those are my type 8s and my type 1s. But the one that I'm actually looking for are the link local ones. And external database summary. I wonder if I have to do a show OSPF database to get those. prefix router, NSSA external. Let's see here. These are my type 8s, which should be my link states. My type 9s should represent my intra-area prefix LSAs. So let's try prefix. Okay, yeah, so these are my type 9s. And then the link would be my type 8s. But the only thing that's kind of throwing me off here is that I'm not seeing the link local information, the FE80 addresses. I'm probably going to have to, oh, there they are. I just didn't go far enough. There we go. This is what I would expect to see with the type 8 LSAs. I would expect to see link local information. So I must not have been looking in the right spot. And we'll talk more about these in a little bit. Let's go back to the type 9s, which would be, again, these prefix LSAs, the intra-area prefix LSAs. These are the ones that are going to be tied to the type 1s that we have as well. Notice here what it describes. These are my type 9s. It describes the actual prefix, 192.168.1. Remember, this is the advertising router, which is router 1. If I go back to my topology, that is the loopback on router 1, which is an internal network to area 0. So it makes sense that that would be described as an intra-area prefix LSA. It gives us the prefix. It gives us the prefix linked, which represents the subnet mask for that particular destination. It gives us the metric, which is the cost. It's a loopback interface, so 10 to the power of 8 divided by the 8 million kilobits per second on the loopback is going to result in a cost of 1. Remember, we only use whole numbers in this case. We would see, hopefully, the 14 subnet as well. Yep, there's the 14 subnet, and that's a /30, and that, again, describes the type 1, essentially the type 1. Now, if I was running OSPF v2, we would not have these type 9 LSAs. We would only have the type 1 LSAs that represent those prefix destinations. All right? So that describes the type 1s and the type 9s. Let me go back to where I was here. We were just looking at the database, but I want to make sure I'm in the right spot. Here's the database. So now let's talk about the Netlink States. All right, specifically on router 4, again, we're looking at this from the perspective of router 4. I just simply go in here, show IP OSPF database net to look at the Netlink States. And again, the DR is responsible for generating this type of LSA. The advertising router for this LSA is 1.1.1.1. So that tells me that router 1 is the DR for this multi-access network. Because router 4 is not originating those type 2 LSAs, router 1 is originating the type 2 LSA. Okay? What does it describe? It describes who's attached to the network. That's it. It doesn't describe the network itself. It basically says, I am the DR. These are the subordinate routers, or these are the other routers that are participating in that network segment. And by the way, the interface ID, this number here represents the interface ID of the DR. Now, if I do a show IP OSPF database, you will see here for the Netlink States, the advertising router is represented by the router ID of the DR. So for area 0, I can tell that router 1 is a DR in area 0. If I scroll down, I should see the other areas listed. And let's keep going here, keep going. Well, this is router 4. So let's go to router 1, show OSPF v3 database, show OSPF v3 IPv4 database. You'll see here for router 1, because router 1 is participating in multiple areas, you'll see all the area 0 information, then you'll see the area 1 information. So it looks like for area 1, I don't have a DR, because all I see is my type 1s, my type 3s, my type 4s, my type 8s, and my type 9s. And area 2, I have type 1s. In area 2, I have type 4s. So router 3 is the DR for area 2. These are my type 3s, which makes sense. These are all generated by the ABR. The ABR in our topology is router 1. These are my type 8s, which describe those link local information. And then these are my type 9s. All right? And then my type 5s for my external LSAs, which are being routes that are redistributed from another autonomous system. All right, so the network LSA is an LSA that describes essentially who's attached to that particular area or that particular broadcast domain. That the router 1 is the DR. There are 2 routers that are attached to that link. Again, it's all about routing to nodes, not routing to networks. So when everybody wants to talk to those devices that are attached to this multi-access network, they're going to send that information to the DR, and then the DR is responsible for propagating that information to the rest of the routers within that broadcast domain. Make sense? Now let's take a look at our inter-area prefix LSAs. These are my summary LSAs. If I go back and look at my topology, I should see type 3s for the 12 subnet, the 2 subnet, the 13 subnet, and then also all those other loopbacks, those secondary addresses that we have on router 2. So if I go to back to my database on router 4, and I just look at the database in general, we can see all of those type 3 LSAs. This indicates that we've had one update, right? Because again, the sequence number starts at 1, and it increments each time we get an update. Most likely this is because of the Paranoid update. It's been 30 minutes, been an hour actually, so we should be getting pretty close to getting a second increment here when we hit our 60-minute mark. But these are all the prefixes that came from other areas. All right? Now, remember, in OSPF, summarization does not occur by default. Summarization is something that you have to configure. So let's say that I was going to summarize these networks here. Let me go ahead and copy those into Notepad. That's not really the point of this discussion here. We actually have another lesson that we're going to do where we're talking about summaries. But let's say that we were going to summarize these prefixes from area 1 into area 0. All right? And so this will be a little bit of a hint as to what we're going to be talking about later on. So we've got what? 1, 2, 3, 4, 5, 6, 7, 8 prefixes that we want to summarize. Starting at 16, that's actually pretty good. One of the quickest ways that you can figure out what a summary is supposed to be is the number that you start with. We all agree that the summary is going to include 192 and 168 because that's common to each of the networks. Whatever number you start with has to be evenly divisible into the binary block that you're going to summarize. 16 is evenly divisible by 8. So I can create a block of 8 starting at 16. 256 minus 8 equals 248, which means my subnet mask will be 255.255.248.0 for my summary, and the prefix I'm going to use is 192.168.16.0. So my summary ends up being /21, right? 16 plus 5. So this is going to be my summary to include all of these prefixes here. 16, 17, 18, 19, 20, 21, 22, 23. That's a block of 8. All right? As long as the block size you're creating is evenly divisible into the address that you're starting with. So for example, I could not create a block of 32 starting at 16 because 16 divided by 32 is not a whole number. It's kind of a quick cheat sheet way of figuring out what the summary range could be. You could do a block of 4, you could do a block of 8, you could do a block of 2, because all of those result in a whole number when you use them as the denominator, but you could not do, say, a block of 5, right? You could not do a block of 7. because it's always powers of 2 math. All right, you could do the bit comparison if you want. If you want to do the traditional method of calculating the summary, you could do the binary comparison. But in our case, we're kind of using the cheat sheet method. So let's say now that I want to go ahead and generate that summary. We would do that on router 1 using what we call the area range command. We use the summary address command on an ASBR to generate a summary. We use the area range command. And again, we'll see this later on because that's kind of part of the another discussion that we have. So if I do a show run pipe section router here, I can see what my configuration looks like. And we're running OSPF v3 in this case. So config T router OSPF v3 1. And we're going to go into our OSPF v3 1. And we're going to go into our address family for v4. And we're going to simply say area range. Now, when we use the area range command, we always specify the area from which we're summarizing, not to which we're summarizing. And we're summarizing from area 1. All right? Again, we'll see this later on, but I'm going to create a summary from area 1. It's going to be 192.168.16.0/21. Oops, area range. I forgot my range command. 192.168.16.0/21. Oops, 255.255.248.0. EIGRP allows you to use a prefix notation, / notation. OSPF doesn't. Now, I'm only doing that in IPv4. I would do a similar thing in IPv6. Obviously, it would be v6 prefixes, but we don't really have anything to summarize in v6. So we're not going to do that. But now if I go to router 4 and I refresh my database, you will see that I'm no longer receiving all of those individual prefixes. I'm receiving a /21, and the age it's brand new, right? This is the first time I've seen this update. It's brand new, /21. So that's kind of the point of a summary LSA. It's to summarize prefixes from one area to the other using the area range command. So let's drill down and see remember, this is the summary of the database. Let's drill down and see what that looks like, what the actual LSA looks like. So again, show IP OSPF database. In this case, we're looking for inter area because those are my summaries from one area to the other, inter area. And I need to specify prefix LSAs. Remember, these are inter-area prefix LSAs. Remember, inter-area router LSAs are type 4s. They describe the ASBR. Inter-area prefix LSAs, they're called prefix LSAs because they represent network prefixes. These are my type 3s. All right, so that's, again, something specific to, gosh, could spell right. That is something specific to OSPF v3, okay? So inter-area prefix LSAs, the advertising router is the ABR. In this case, that's router 1. And the number of prefixes in this particular LSA, so the 1.0. Now this is the LSA. 1.0 describes, I'm on router 4. This is Intra. I mistyped it. I was wondering why it was showing me the 1.0. I need inter-area prefix. I forgot to put the inter-area in there because it didn't make sense. 1.0 is in the same area as router 4, so that's an intra-area prefix. So here's my inter-area prefix LSA. Sorry about that. But it's still the same advertising router as the ABR. There's the 12 subnet. That's the link between router 1 and router 2. There's the subnet mask. There's the metric to get to that. Now, this is interesting because I'm on router 4, right? And if you were to do the metric calculation, you've got a serial link here, which is 1.544 megabits per second. The formula for the metric is 10 to the power of 8 divided by the link bandwidth in bits per second. So 1544, that's kilobits. 000 would be bits per second. So the cost of that link is 64. all right? But I'm on router 4. So it's when router 1 is advertising the prefix, and this is what I was talking about, routing to nodes as opposed to routing to networks. It's advertising this prefix destination from the perspective of the ABR. So this is not the overall path cost from router 4 to reach that destination. That is the path cost from the perspective of the ABR. I use my type 1 LSA to identify the cost to reach the ABR because the ABR is in the same area that I'm in, and that would have a cost of 10. So the overall path cost should be 74 because Ethernet 10 to the power of 8 divided by 10 megs per second is 10. So the overall path cost is 74. In fact, if I do a show IP route or show OSPF v3 route, show IP, well, let's just do show IP route. Actually, it probably won't show anything. Yeah, it does. Okay. Notice the cost for that 12 subnet is 74. So this goes to what I was saying before about the concept that OSPF is concerned about routing to nodes, not to networks. Yes, we're learning network reachability information, but we're trying to route to this node. So this type 3 LSA describes the prefix, but I don't use the type 3 LSA to route to that prefix. I use the type 1 LSA to route to the ABR, and then the ABR in turn will use its type 1 LSA to route to the destination. We're just advertising the reachability information. It's kind of confusing, but it's how OSPF does routing. It's not like your traditional routing protocols. All right, so that's our 12 subnet, and then we have more. I didn't finish showing you the rest of them, but they're all going to look about the same. There's the 2 subnet with the /24. And that has a metric of 65. Keep in mind that's a loopback interface on router 2. The cost of the serial link is 64 plus the loopback is 1. So from the ABR's perspective, it costs 65. Here's the 13 subnet. That has a metric of 10. Keep in mind that's the Ethernet link over here. So that's going to have a cost of 10 because Ethernet is going to have a cost of 10. And then we see the summary. We should see the summary now. Here's the 16 subnet /21. That has a metric of 65, which is kind of interesting as well, right? Because the summary is describing the loopbacks. Those secondary addresses on our loopback interfaces, that's what the summary is describing. Well, the cost of a loopback is 1. So that's why we see the cost is 65 there. It takes the lowest metric of all the routes that are included in the summary, and that makes that the seed metric for the summary itself. All right? So again, these are my type 3 LSAs. All right? Now let's take a look at the inter-area router link states. These are my type 4 LSAs. You will only see type 4 LSAs if there's an ASBR. That's it. Type 4 LSAs represent reachability to the ASBR. Type 5 LSAs represent the external networks. So if I come in here now and I say, okay, show me these inter-area LSAs. So again, I'll come here, show IP OSPF, show OSPF v3 database, and question mark, inter-area prefix LSAs. So again, we're looking for the LSA that describes this ASBR. All right, going back up to our database here, that's this LSA, inter-area router LSA. So I'm going to say inter-area router LSA. And this describes the reachability to the ASBR. The advertising router is router 1. So the ABR is generating this type 4 LSA, inter-area router link, but look at the destination router, 3. Okay, router 3 is the ASBR. So notice it doesn't describe anything about the external networks. It doesn't describe the type 5s. It doesn't describe the redistributed routes. It simply describes who is originating external routes. How do I get there, or what does it cost me to get there from the perspective of the ABR? And then again, I would use my type 1s to get to the ABR. Okay? So that's my type 4. Now those type 4s are going to propagate into every area except for special area types. Remember, not so stubby, totally not so stubby, those area types are not allowed to have external routes, so there's no need for them to have type 4s. So if area 1 was an NSSA, for example, or area 1 was a stub area, the type 4 would not be sent into that area because the type 5s are not allowed in that area. So there's no reason to send the type 4s in because the type 5s are not allowed. External routes are not allowed into special area types. Okay? We're getting there. We don't have type 6s to worry about. We do have type 5s. So again, if I go back to my database, the type 5 LSA, which is my inter-area router link states, not my router link states. The type 5s are actually below the type 8s for some reason. I don't know why they did that. The type 8s and 9s, everything else is in order, right? You got your 1s, you got your 2s, you got your 3s, you got your 4s, and then all of a sudden they go to 8 and 9, and then they put the 5s at the end. Doesn't make a whole lot of sense. But type 5 are my external link states. Notice the advertising router here is router 3. Router 4 doesn't have a relationship with router 3. Router 3 is in a completely different area, but router 4 has a relationship with router 1. That's why the type 4 LSA is so important, because it's that relationship with router 1, that type 4 LSA, that allows me to know how to reach the ASBR. All right, so let's take a look at our type 5s. Here we're going to look at our type 5s by using the word external, which represents the type 5. AS external link, the advertising router, is the ASBR. This is the destination address. This is the prefix length. This is the metric type, which in this case is E2. Metric type is it a type 1? Is it a type 2? Type 1, the seed metric will increment, and type 1, the seed metric will stay or type 2, the seed metric will stay the same. And this happens to be the default seed metric for redistribution into OSPF. We could change that. We could change it to a type 1. In fact, let me do that real quick. Go to router 3. And let's do a show run section OSPF just to see how the redistribution is taking place. They are just simply doing redistribute static. So I'm going to change that behavior. And I'm going to come into OSPF and under address family v4, and I'm going to say, address family v4, and I'm going to say redistribute static, and I have the option now of setting the seed metric if I want to change the seed metric, or changing the metric type. So I could say metric type 1 for E1, and then I could say metric if I want to put in a default seed metric or a different seed metric than the default. So basically I'm just redistributing. Now I'm sending it as an E1, and I'm putting in a seed metric of 100. So now if I come into my router, I'll see that reflected here. It's coming in as a type 1. The seed metric is 100, but if I do my routing table, you can see it comes in as an E1, but the metric is incrementing. So the costs of the links along the way are being added to the initial cost that's being sent in by OSPF. That's the difference between E1 and E2. E1, the metric increments, E2, it doesn't. We only have one ASBR originating that prefix, so there's really no need to send it in as an E1. There may be reasons why. Typically, if you have an external route that's coming from multiple sources, the same external route, you might want to send it in as an E1. All right. If I do a show IP route 10.0.0.0, let's do /, is it a 16? I think it's a 16. Show IP route. Let me see. I was going to try and I'll do that in a minute. I want to continue on with our previous discussion, right? Looking at the database. All right. The Type 4 LSA, like I said, describes reachability to the ASBR, but the Type 5 LSA describes the actual external network. Let's go back to that actually, external. So we can see right here, there's the V6 one as well. You notice it really pretty much looks the same, right? The format is the same. The only difference is we have a V6 prefix represented instead of a V4 prefix. But here's the destination, here's the prefix linked. Now it's coming in as a type 1 and a metric of 100. Now, if this was a special area type, that route would come in as a type 7, and then it would get converted to type 5 on R1. So I'm going to convert this area to a not so stubby area so that we can see that happen. Let's go to router 1. Do show run section router. And I want to make area, basically we'll just make area 1 or area 2 NSSA. It has to be either NSSA or totally NSSA because it has an ASBR. We cannot make it a stub area or a totally stubby area because you're not allowed to have special routers or external routers in a special area. Excuse me, you're not allowed to have external routers in a special area type that's not NSSA. So we're just going to come into our address family. We're going to say area 1. They're implemented on all the routers in the area. For special area types, we don't make one router a special router, we make the whole area special. So now if you're doing no summary, like area X NSSA no summary, making it totally NSSA, that's done on the ABR, but everybody in the area has to have the same special area flag. That's part of the hello packet, and they will lose their adjacencies if they don't have the same flag. So we'll see that actually happen as soon as I convert the area 2 to NSSA on router 1. So area 2 NSSA, done. It's now a special area type, but I lost my adjacency to router 3 because router 1 is sending that flag in. Let me see if I can kind of capture that for you and show you. Let's do a capture real quick. And there's it's part of the hello packet, right? There's a flag that's sent that describes this router as basically has that flag set, describing this as a not so stubby area. All right, and router 3 doesn't have that flag, so it's losing that information. Let's see, it's going to be router 1, and where's my hello packets? Router 1 to all routers right here. All right. And if I expand this, this is the standard OSPF header. We talked about that before, right? Just gives me my basic information about the router. But you'll notice here the N bit is set, right? Indicating that this is a not so stubby area, right? So that's, if I was to look at the hello packets that are being generated by router 3, you would see that bit is not set. So because that flag is not set, we lost our adjacency. So let me go ahead and set that on router 3. I think I'm already in the address family, so let's just do area 2 NSSA. Now we should get our adjacency back, and if I'm looking at my captures still, I should see, I think I'm in the right, yeah, I should be in the right, because I was doing the metric type before, redistribution. So now if I go back to my captures here, I should see in the hello packet from router 3 that that N bit is set. So that's the flag that has to be set for them to be able to form that adjacency. All right? Not so stubby area. So what does that mean from the perspective of my link state advertisements? If I go to router 4, nothing changes. I'm still going to see on router 4 the external LSA, type 5. But if I go to router 1 and I look at the database on router 1, show IP OSPF, so show OSPF v3, IPv4 database, you will see that I'm getting type 7s in area 2. I have to look at the specific area. Where's my type 7s? Right here. So I'm getting these type 7s. Type 7 is exactly the same thing as a type 5. It's just an external LSA inside of a special area type. Special areas are not supposed to have external routes by definition, but this is an exception to the rule. This type 7 describes the exact same prefix information that type 5 does, and in fact, when the type 7 hits the router 1, it gets converted to a type 5. So everybody else looks at it like a normal type 5 route, whereas in this area it shows up as a type 7 route. Okay? All right. So the only two LSAs we have left are 8s and 9s. All right, the 8s and the 9s. I'm not sure what else they're having us do here. They kind of probably have us just summarizing all of this information that we talked about. So we're almost done here, but let's take a look at the 8s and 9s. Link LSAs and inter-area prefix LSAs. Where is that? Right here. Inter-area prefix LSAs. That is the inter-area router link states. But let's take a look at the type 8s. We kind of already did previously. Let's do it on router 4 since that's what we've been doing for the most part, looking at everything on router 4. So going to type 8, you can see that router 1 is generating them, router 4 is generating them. Remember, these type 8s are link local scope. So if I had other routers in area 0, but they were maybe on a serial link or on a different broadcast domain, I would not have type 8s from those other peers. I would only have the type 8s from people in my common subnet. There's two routers in this subnet, router 4 and router 1. So that's where the type 8s, the scope is going to be limited to. If there was another router behind router 4, router 1 would not see that router's type 8s because they're link local scope. So what do those advertise, right? Link states. And we do see link information, right? But we're seeing specifically host address information. So this is the specific IP address on that link. All right, so this is very, very similar to like what maybe a type 1 LSA would look like in OSPF v2. This is the prefix, this is the prefix length. But then we also see for the IPv6 stuff, that's the IPv4 information. But this is really the most important piece because this is unique to IPv6. We see the link local information. This link local information is really, really important because in IPv6, adjacencies are formed with link local, next hop addresses are link local, neighbor discovery is done with link local addresses. So this is really the unique piece to these type 8 LSAs, describing the link local addresses. Now in this particular case, we're also describing the global unicast prefix that exists on this router as well. All right. Prefix length is /64. This is the 64-bit network ID for that particular network. All right. We already did take a look at the type 9s, but we'll take a look at it one more time. The type 9s are my intra-area prefix link states, and that would be the prefix and intra-area. Let me see here. Intra-area. Hold on. Let's see. Not inter-area. Yeah, inter-area. Stupid. Not intra-area. all right? Intra-area would be my type 3s though. We're looking for intra-area prefix link states, which would be internal, I believe. No, that wouldn't be internal. Let me see. Link internal. I think this is, yeah, these are the ones. It's the same as what we saw before. Hold on, I'll get there eventually. I get a little confused because we're running OSPF v3 as opposed to just OSPF v2. It must be prefix. What am I missing here? Let's take a look one more time. Intra-area prefix Lsas, intra-area prefix Lsas, which would be not advertising router, not internal, not network. These are type 4s, or type 2s. These are type 8s. These are type 3s. These are type 5s. These are type 7s. These are type 1s. It's got to be prefix. Internal. Intra-area prefix. Yeah. There we go. Intra-area prefix Lsas. All right. I think I did that before. I don't know why I didn't show that. But yeah, we're looking for those intra-area prefix Lsas. These right here. Sometimes it's if you don't do it a lot, it's kind of be a little confusing figuring out. I wish they would just name them, right? If I want to see type 9s, just show me type 9, right? They did it for type 5 and 7. They just put type 5 and 7 here. So why didn't they just put type 9, type 8, type 3, and so on? Type 4, type 3, and so on. But anyway, I digress. Okay? So taking a look at those, it pretty much describes the networks that are attached to the routers, right? These intra-area prefix Lsas. This is the advertising router, which is the owner of that LSA, basically, in this particular case. This is the network. This is the prefix length. This is the metric to reach that destination. That's a loopback. This is the metric to reach that destination from the advertising router's perspective. That's important to note. All right. So, for example, the 14 is going to have a prefix length of /30. It has a metric of 0 because router 1 is directly connected to that particular network. So it doesn't really have, we don't have to go anywhere to get to that destination. Certainly it still has a metric, right? It still has a metric, but it is a directly connected route. All right. So that really is the kind of the whole discussion of all the different LSA types. Like I said, we didn't look at 6s, we didn't look at 10 or 11 because we don't really see those that often. But hopefully that helped kind of clear up a little bit, you know, how this information is propagated. Now, certainly, there's more information we could discuss, right? Particularly how we can control the propagation of LSAs, how we can manipulate them, but we'll get into that discussion a little bit later on. All right? Yeah, we will. We're going to discuss special area types. We have a chapter that we go through that. I can kind of summarize it real quick before we wrap up. A normal area, of course, is any area that isn't a special area type. Area 1 and 2 in this particular case, well, 1 now. Area 2 has been configured as an NSSA. Area 1 is a normal area, which means that everything is allowed to come in and everything is allowed to go out. When I'm talking about everything is allowed to come in and go out, I'm talking about the LSA types. The backbone area can never be a special area type. So it's always allowed everything in and everything out. The purpose for configuring a special area type is to limit the amount of information that gets sent into the area. And it, it could be for the purposes of, maybe there's only one ABR and we don't really need anything else coming into that area. We're going to use some default route to leave the area or whatever. There's 4 different special area types. In Cisco's world, there's 4 different special area types. There's stubby, there's totally stubby, there's not so stubby, and then there's totally not so stubby. Okay? Or some say NSA total or whatever. But first of all, let's talk about the stub area. If area 1 was configured as a stub area, everything is allowed to leave the area. In fact, any special area type doesn't restrict what can leave the area. It only restricts what can come into the area. So if I was to configure area 1 as a stub area, the only types of routes that are allowed to come in to that stub area are type 3s. Type 5s are not allowed. External routes are not allowed into a stub area. In fact, external routes are not allowed into any special area type. But by configuring this area as a stub, R1 is going to automatically inject a default route. So we can still reach those external networks. We would just reach them using a default route as opposed to using the actual defined external route. So a stub area doesn't allow type 5s. Totally stubby doesn't allow anything in. No type 5s, no type 3s, only internal routes, and a default route. A default route will be injected by router 1 when you configure this as a totally stubby area. You do that by saying on router 1, area 1 stub, no summary. All right? If you want to just make it a stub, it's just area 1 stub. If you want to suppress type 3s, area 1 stub, no summary. An NSSA, a not so stubby area, is exactly the same as a stub area, with the exception that you can have an ASBR. Remember, external routes are not normally allowed in a special area type. Not so stubby means literally, it's kind of stubby, but we have an ASBR, so it's really not that stubby because there are some external routes. That's the way I look at it anyway. So in a not so stubby area, which area 2 is configured as, type 3s are allowed in, but type 5s from other areas are not allowed in. And you're allowed to have an ASBR, which includes type 7s. Those type 7s get converted to type 5s when you leave the area. So a not so stubby area, and by the way, this is the only special area type where a default route doesn't get injected automatically. So you have to take that into account. You can override that behavior by injecting the default route, but in a not so stubby area, only type 3s are allowed in, but you're allowed to have an ASBR. So stubby and not so stubby are pretty much the same, with the exception of one allows an ASBR, one doesn't allow an ASBR. Totally not so stubby, or NSSA total, or whatever you want, however you want to call it, you're allowed to have an ASBR, but nothing is allowed to come in. No type 3s in, no type 5s in, only a default route comes in. And that happens automatically on router 1. So you could say, for example, on the router, so the ABR would look like this, area X stub. That would be a stub area. And then the internal routers would be just area X stub. Okay. If you wanted a totally stubby area, you would say area X stub, no summary. And this is a totally stubby area, total stub. And then on the internal routers, you would just say area X stub. So you would only put the no summary on the perimeter router, which makes sense because totally stubby is doing what? It's suppressing summaries. It's saying summaries are not allowed. No summaries are allowed. That makes sense. All right. Now, if it was going to be an NSSA, I'll just do it here. If it was going to be an NSSA, area X NSSA, so that's not so stubby, meaning that you're allowed to have an ASBR in that area. And it would be the same on the internal routers. And then for a totally stubby NSSA, so basically you're just replacing the word stub with NSSA. And the not so stubby, totally not so stubby. Not so. There we go. All right. And then on the other routers, you would just do area X NSSA. So these are special cases where you want to restrict what comes in, what doesn't come in, and so on. The stub will get a default route injected automatically. Not so stubby. Let's take a look, right? Let's go to router 3. We already configured that area as a stub area. Do show IP route. We can see a gateway of last resort is not set. So remember I told you that when you're doing not so stubby, no default route is injected automatically. No default route injected. All right. And in this case, in the other two cases, the default route is injected. And totally NSSA default route is injected. Now you can override that behavior. We would pretty much want a default route because we would still want to be able to reach those other networks that are being suppressed. So what you have to do, show run section OSPF, is you have to tell the router that you want to send a default route in for the NSSA. So config T, and this is only this case, not so stubby. Address family unicast and area 2 NSSA and default information originate. And we can put in the metric type if you want. So normally a default route would come in as an E2. I could say metric 100, metric type 1. And then if I go to router 3, I'll see that it's now getting an ON1 route. It's an N because it's a not so stubby area, so it's coming in as a type 7. But this is kind of the exception to the rule. All right? Make sense? So that is kind of a summary of that. I'll probably do another, well, we're of course going to do another session, and in the other session I will kind of go through and talk about the special area types. But we're going to kind of wrap up this session. Andre, welcome. Sorry you missed the session, but hopefully we'll see you in the next one. All right. So we'll wrap up this session, and hopefully we'll see you guys in the next one. All right.